In Chapter 15, we discussed non-renewable energy resources, and in the first part of Chapter 16, I covered renewable energy. This last portion of Chapter 16 covers the best energy option, the reduction of energy waste. Let's be honest, the future energy needs of the Earth cannot be met with fossil fuels. Their limited supply and the increased cost of exploiting less accessible resources dictate that alternative energy sources must be developed to replace them. As alternative energy sources are scaled up to meet the world's energy needs, the use of fossil fuels must also be conserved. Energy conservation simply refers to strategies that reduce the amount of energy that is being wasted. There are many ways for individuals to conserve energy, and that's what most of this video will be covering. Energy efficiency is the ratio of the quantity of work or energy that is produced to the quantity of the energy that was used to make it. A concept we have to remember is the second law of thermodynamics. Remember, the second law of thermodynamics states that no energy transformation can be 100% efficient, and that some waste heat must be produced when energy is converted from one form to another. While we can't create a 100% truly energy efficient product or service, we can improve the efficiency of the products and services we use. Currently, 84% of the commercial energy in the United States is wasted. We're only properly using 16%. Some of this is due to heat loss, but half of that loss is due to fuel inefficient vehicles and furnaces, as well as poorly insulated buildings and leaky systems. Another idea to consider when making suggestions for energy changes is the life cycle cost of the energy source. This doesn't just include what you pay up front, but the cost of maintenance and eventually disposal as well. The least efficient energy-using devices we use today are incandescent light bulbs, gas-powered vehicles, and nuclear power plant energy that is used just for space and water heating. These are all cheaper alternatives up front in comparison to fluorescent bulbs, alternative fuel vehicles, and certain renewable sources of energy. This is the main reason many people choose them over energy-efficient alternatives. We still use coal in the United States because subsidies have made it extremely cheap to use, but 2/3 of the energy produced from coal is lost in the form of heat. The last major idea we need to consider when switching to other energy sources and products is to look at the net energy efficiency. This looks at not just the amount of energy lost during the transfer of the energy, but also accounts for any energy used to obtain or transport the energy in the first place. It looks at every single step of the process to ensure we are minimizing our energy waste as much as possible. Is recycling the energy we use the answer to increasing the energy efficiency? No. That's actually not possible based off of the second law of thermodynamics. Some of the energy will always be lost in the form of heat, so it isn't truly saving much considering the amount of energy you would need as an input to recycle it. The best way to improve energy efficiency is to slow down the rate of energy lost at each step by following certain guidelines. In houses, the two biggest things you can do are to improve insulation and repair leaks. You can also switch to a solar water heater and space heating systems to reduce the amount of steps between the energy production itself and finally reaching your house. In industry, we have what is known as cogeneration. Large companies and power plants that burn fuel often waste excess heat by expelling it into the surroundings. In some cases, that excess heat can be used to produce steam that will generate electricity. If the excess heat is insufficient for generating electricity, it may be used to heat nearby buildings, thereby reducing the need to burn additional fuel. Industry can also do smaller things, such as switching from combustion and electricity-based engines to hybrid engines and switching to more efficient lighting. As for transportation, we can reduce driving by switching to using more mass transit, walking, carpooling, or riding a bike. Governments can help conserve energy by mandating energy standards. In the United States, for example, the Corporate Average Fuel Economy, or CAFE standards, were first enacted by Congress in 1975 to require automobile manufacturers to produce cars that meet a minimum fuel efficiency standard. CAFE standards were effective in raising the average mileage for cars in the United States from 13 miles per gallon in 1973 to 22 miles per gallon in 1985. An addition in 2012 will lead to the average mile per gallon increasing to 54.5 miles per gallon. These standards can be achieved by better engine design, efficiency, and weight reduction. We also have the Energy Star program, which was put in place to protect the environment by setting requirements of energy efficiency standards in order to obtain an Energy Star certification. It's that little emblem you see on appliances in your kitchen. In just the year 2005, this program helped eliminate as much as 23 million cars worth of greenhouse gases from the atmosphere. Conventional gasoline-powered vehicles run off of an oil derivative that is highly polluting, but they can travel long distances between each refuel and can maintain a proper speed on the highway. Electric vehicles are much less polluting, but can only travel small distances between refueling, and the recharge time is much higher than we would like. Hybrid electric vehicles are becoming more common. These cars use a relatively small amount of gasoline by combining an electric motor with a small gasoline engine for vehicle propulsion. Some of the kinetic energy of the car is used to drive an alternator that charges the battery needed to power the electric motor. Hybrid electric vehicles can have efficiencies several times that of a typical automobile, getting up to 40 to 50 miles per gallon. Electric vehicles and plug-in hybrid vehicles both use electricity to charge batteries in the car. This likely utilizes electricity from an electric grid. Ideally, this electricity would be generated using an alternative energy source like solar or wind. However, if the electricity was produced by coal or natural gas-fired power plants, then the fossil fuels will still be consumed, though indirectly, to power the vehicle. By diverting the energy generation from the internal combustion engine of the car to a power plant, the consumer is trading off some of the environmental costs of operating a gasoline vehicle with those of operating the power plant. It will still reduce the environmental cost of operating the vehicle either way, but using alternative energy sources to provide the electricity for the electric car or hybrid car is the best option for conserving fossil fuels as well. Another type of alternative fuel used in cars was mentioned in the non-renewable energy debate, natural gas. Natural gas vehicles, or NGVs, are not widely used mainly because the technology is still new enough that it hasn't caught on very well. One of the biggest things holding us back from making the switch over is the lack of pumping stations. However, driving one of these vehicles means cleaner emissions and less wasted fuel due to a higher energy efficiency. Looking at buildings we have already built, the two biggest steps you can take to increase energy efficiency are better insulation of any potential sources of heat leaks and just turning off energy-using devices when they are not actively being used. Better insulation in the walls, on the roof, in the windows, and on the water heater, that is. The next big step is to switch over the lighting to more efficient bulbs. Options for new buildings include building an eco-roof and taking advantage of passive solar heating techniques. Both of these have many other benefits as well. For example, eco-roofs can absorb excess water or stormwater and use it to grow plants instead of flooding the yard and sewers. During this century, there will likely be a shift from large centralized macro power to smaller decentralized micro power. This would be a shift from major fossil fuel-fired power plants to more renewable power plants that are much smaller and more local to the area receiving the final electricity. This would be a very flexible system that could accommodate changing population sizes as they increase or decrease, due to the relative simplicity of moving a smaller power plant to another location in comparison to the larger power plants we would have before this. Since there would be fewer steps between the actual source of energy and the final destination, the system would be of a higher efficiency overall. Being separated into smaller chunks, it would be easier to maintain and fix any problems, and the likelihood of massive power failure is slim to none. However, it would be expensive to build in the first place because it would be a complete overhaul of much of the system we currently have in place, which means that it would also require more land as well. Governments have the strongest chance of determining what type of energy resources are used in their country or state. The subsidies we have covered for all of the energy resources from chapters 15 and 16 are controlled by the government. Governments have three options for energy resource control. The first is to take a hands-off approach and allow a free market. The second requires keeping prices artificially low to encourage the use of certain sources. And last, keeping prices high to discourage use overall. Obviously, the United States uses the second option, based off of the pie chart I provided. Economists claim that the third would be the best option, and environmentalists obviously agree. Most options that will lead to a sustainable future revolve around switching to more fuel-efficient vehicles, reducing demand for energy, increasing research for renewables, breaking up subsidies for non-renewables, and improving the efficiency of common household appliances. Here is your AP tip, the last one from these videos. A common prompt in the free response section of the APES exam is to request a description of ways to reduce the environmental costs associated with an activity like burning coal. Often, the best way to respond to such a prompt is by invoking conservation. We've said it multiple times now. By using conservation strategies like those mentioned in this video, you may be able to avoid a lengthy description of a complicated technology. For example, it is easier to describe the act of turning off the lights when leaving a room to lower electricity consumption and thus eliminate sulfur dioxide emissions than it is to describe the operation of a wet scrubber on a coal-fired power plant to eliminate those same emissions. Just something to think about. And that wraps up my last video. I know you're going to miss these. I hope you enjoyed it.